Hey guys, so I made a predictive model for NFL games. I was gonna use that to look at the betting on the NFL games given the line and the over under. Should I work this? There we go. Okay, yeah. So in 2018, the federal ban for sports betting was lifted, and since then, 11 states have legalized it, with another like 24 planning on legalizing it within the next 5 years. So this is gonna create a very large uh you know very large just market, and it's going to be a big source of revenue for a lot of different states. So with that in mind, I was hoping to see if I could figure something out that would help predict it and maybe be able to monetize it in some way. So I was able to find a data set on Kaggle that had games, NFL games back to like 1970, um, and they all had the like final score and the lines and the over unders for each game. But I decided to only do games in 2019 because a game in 1975 is going to have a lot of different factors or a lot of different predictions for the score than a game in 2019. So what I needed to do to clean it was the half of the team names were like the length of the team, like the Indianapolis Colt. When there was other things where it was like the team abbreviation you see on the scoreboard. So for the Colts, it would be an IND. So I wanted to make those match. And then I needed to make the playoff weeks the actual week number instead of like rounds, so then they could be a numeric field. So like right, but starting there were like wild card, and I just made those week 18. And then again, I wanted to map statistics for each team, like the team averages for the season, so like points, the average points for the offense, the average passing yards, like the average yards given up by a defense. And then I wanted to make the line both negative and positive. So an away team is favored, it will become if an away team is favored by three, it would become +3 instead of the -3 that it was in the model, just so I could be able to differentiate it. And here's a cool graph that I found. This is the line of games from 2000 to 2019, 2000 season 2019, and it's very bimodal. As you can see, there's the when a home team's favored, it's you that's centered around three, and then when an away team's favored, it's centered around three also. And usually the 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 like the uniform thing to do is if the teams are even, usually you favor an away team or you favor a home team by three, just give them 3 points usually for playing at home. And as you can see, there's not a lot of games where it's the line zero. So then when I was exploring, I wanted to figure out something like usually later in the season teams start to score more, and this is the week by here's home points and then by away points. And I did an ANOVA test on this to see if it is a good if it's different per week. And for home the p value was 0.09, and for away for some reason it was 0.91. So the week definitely has an effect on the home score. So I decided to add that in. Even though it's not at a 0.05 threshold, I still thought it'd be a good predictor. So I used that. And then this is the home average points for, so if a team plays their home games in a dome, that it's here, and then if they play home games outdoors, it's there. And the uh, p value for that was 0.01. So I for sure was like, I need to use the dome in my model. And then I just started doing the average points by like passing yards and rushing yards. This is the two strongest correlations. They weren't great. They were 0.48 for the pass yards to points, and then 0.59 for rush yards to points. So those were the two highest absolute values for correlations. And then for my model, I did multiple linear regression models. One to try to predict the points for the home team, and then the other one to try to pick it for the away team. And then I used these models to find a predicted line and a total score. And then I would compare these with the actual lines and the actual over under. So for the predicted line, I took the predicted away score and subtracted the predicted home score. So then if the home team was supposed to win by or it's supposed to win by more, then that would be negative. So that would correspond to the actual line. And then the total score is just a combination of the two. So my results for the 2019 games was I went 144 out of 250 for the over under, which is 57%. I went 139 for 248 for the betting on the lines, which was 55%. And then overall for that, I went 281 for 498 or 56%. And I decided that I would we would bet the over if the predicted points were higher than the over underline, and the under if it was predicted lower than the over underline. And if it was equal, I decided not to bet or wouldn't place a bet. And then same thing for the line. If it was less than the line, you would bet the home team, and then if it was greater than the line, you would bet the away team. And then a 56% is pretty good. They say a good handicap for betting is if you're around 55, you're doing pretty good. My friend who bets a lot, he says that if you get close to once you getting close to 60, you're doing really good. So the model is I feel above average. And then this was what the predicted line for my model was against the actual line. And this again is for games in that were played in 2019. As you can see, the predicted line, it's very uniform, and that's centered at negative 1.49, and then the as you can see for the actual line, it's much less uniform. It kind of looks a little bimodal, or you get a little hump here, but that's centered at negative 1.88. So they're both centered. The mean of each of them are pretty close. And this is the predicted point total, and this was the over underline, and those were centered at for the predicted total was 43.06, and then the over underline was 45.18. And then so I started fitting these for the last couple weeks of NFL games. For week 11, I was 9 for 14 or 64%, which is very good. And then I was 8 for 14 on the actual game lines for 57%, and that came out at 60%, which was pretty good. And then so for the game so far played this week, I was at 61% on the over-under line and the 46% on the actual line. So I was overall 53%. But as you can see, like the model does a lot better on the over-under, and that's just due to there's a lot less variability in that. So you kind of get two spots of variability that the one team can score a lot, but if the other team doesn't score, then they kind of even out. But with the actual line, if one team does a lot better, that's kind of the randomness of sports. And then for my my model itself, the R squared score for my training set against my home model, actually for against both of them, were 75 or 0.75, so pretty good. Not super great, but pretty good. And then for against the validation set, it was 0.8 for the home, and then 0.75 again for the away score. Yeah, well, thank you.